This word is magnet. Let's say that together. Magnet. A magnet is able to attract certain metals. Let's say that together. A magnet is able to attract certain metals. This word is compass. Let's say that together. Compass. A compass is a tool that can be used to find direction. Let's say that together. A compass is a tool that can be used to find direction. Today we're going to read What Makes a Magnet. It's an informative text that teaches us all about magnets. The author is Franklin M. Branley because he wrote the words. The illustrator is True Kelly because she drew the pictures. Let's start by just looking at the pictures. What is this girl doing? I see a fishing pole, but instead of a hook on the end, what does she have? Looks like a horseshoe shape or a U shape. What's happening here? Looks like she's throwing a bunch of different kinds of things inside a box now. Look at this picture. Do you know what these items are? They're all magnets. Do you see the ones on the bottom? They look like the magnets you put on your refrigerator, right? Look at this. I see a pencil and a string and one of the magnets on the very end. Now what is this girl doing? She has that pencil with the string and it looks like she's dipped the magnet down into the box. Almost like she's going fishing. What do you see here? I see the magnet and it's got some paper clips on it and a bunch of other stuff down on the bottom. And what's happening here? I see that little mouse and he's inside the box. Look at all the things still inside the box. What do you see? Now what is the girl doing? I can see her holding a needle. Oh, I hope she's careful. And what's she doing here? What has she got? I see the arrow. I can see her fingers. Looks like a magnet she's holding. I wonder what she's trying to do. I wonder what the mouse is doing here. And the girl too. Look at the needle that she's holding. It's pretty cool. Look at this picture. What do you see? I see the world, the whole earth. Look at this picture. What's the mouse doing? Wonder what's on the end of each of those. Is that a needle? Huh. And then it's in a bowl of water? And now what's he doing with a marker? That needle's still in there. What's on the needle? Looks kind of like maybe cheese or I don't know what that could be. Uh-oh. Look at him here. He got wet. What else do you see? I still see that needle. I wonder what it is on the end of it. I see 2 arrows and 2 letters. What's happening here? I can see the mouse's little hand. He's pulling on that paper clip. The paper clip that's stuck to the end of the magnet. Wow, look at this picture. What's happening? I see a bunch of horses and there's some men on there. Are they dressed like we dress now? No, they're not. So this picture must be showing us a time from a long, long time ago. Look at these 3 pictures. What do all these people have in common? Well, it all looks the same. They're all holding something or using something that has that needle in it. Do you see? Wow, look at this picture. I see a stone, a big stone, and then lightning hitting it. Look at the little lines on the stone. Look at how they're different before and after the lightning hit it. Also, look at that little mouse. What's happening on this picture? I see so many things. What do you see? All right, now that we've looked at the pictures, let's read the words too. Let's go fishing with a magnet. Put different things in a box. A twig and some tacks, a needle, paper clips, some rubber bands. What else? You can decide. Choose things that are small and light. Next, find a magnet. They come in all different shapes and sizes. Tie one end of a string around your magnet. Tie the other end to a stick or a pencil. This is your fishing pole. Go fishing in the box. Put the things you catch in a pile. The others will stay in the box. Maybe you caught some things, but not the others. There's a reason why only some things stick to the magnet. They have to be made out of the right stuff. Anything you lifted out of the box probably has iron in it. The iron in these different objects is ferromagnetic. Iron is not the only ferromagnetic material, but it is the most common. Can you tell which objects in your fishing expedition probably did not have ferromagnetic material in them? Well, look what's still in the box. The wood and a twig won't stick to a magnet because wood is not ferromagnetic. The rubber and the rubber bands also won't stick to a magnet because it's not ferromagnetic. There's something else about ferromagnetic materials. They can help you make a magnet. Want to try? The mouse is saying, some people think all metals stick to magnets, but that's not quite right. For example, aluminum is a metal and it doesn't stick. Start with a sewing needle. Make sure it can stick to the magnet. Place it on a table. Hold it there with your finger on the needle's eye. Rub one end of the magnet along the needle, moving the magnet from the eye of the needle to the point, not back and forth. Do this about 30 times. Then touch the needle tip to a tack, paper clip, or pin. If the object sticks to the needle, you have a new magnet. The magnetized needle might even be strong enough to pick up a few objects. The stronger a magnet is, the more it can pick up at once. So which do you think would be stronger, your fishing magnet or the needle magnet? If you have them, try testing them out. No matter which magnet is stronger, both magnets are small. They can fit in your hand. But there are some very large magnets too. In fact, the whole world is a magnet, even though it doesn't look like one. You can't see the Earth's magnetism, but you can make something that shows you it's there, a compass. Here's what you do. Make sure your needle magnet still works. Then you can get 2 small pieces of foam, plastic, or cork. Carefully stick a piece on each end of your needle magnet. Then float the magnetized needle in a bowl of water. The needle will swing around so one end points north, the other end south. Keep the needle in the center of the bowl so that it can swing around on its own. Then turn the needle around. When you let go, the ends will point the same way as before. This happens because the needle magnet reacts to the Earth's magnetism. To finish your compass, put a dot of ink on the north end of the needle. Then think about where the sun sets. Stand facing that way. Keep this book in front of you. The ends of the needle magnet point in different directions because they're different from each other. Each end reacts to the Earth magnet in its own way. One end will react by moving and facing the north. It's called the magnet's north-seeking pole. And the other end moves and points in the opposite direction, the south. This south-seeking end is called the magnet's south pole. Magnets are strongest at their poles. When you pick things out of your fishing box, they stuck to the ends of the magnet, not in the middle. Poles make magnets work. Magnets make compasses work, and compasses help people find their way around the block or even around the world. Before compasses, people got lost a lot. How were compasses invented? Well, no one really knows the whole story. For sure, it began a long, long time ago. People from different parts of the world knew of this unusual stone. Iron stuck to it. It could be used to make new magnets from iron. And when the stone was used as a spinner, it came to rest with one end facing north and the other one south. This natural magnet stone was important for making compasses. Some compasses were very simple, stones hanging from a thread. They would turn and point kind of like your compass needle. One compass from long ago was called a fish compass. It was used making a magnetized iron shape like a fish, and when they placed it in the bowl of water, the fish would float to the top and line up north to south. Nowadays, sailors, hikers, and pilots use different types of compasses to track where they're going. Compasses help explorers travel the world. They would return home with new ideas, food, and art. So much happened because people were curious about magnets. Lightning. A bolt of lightning has magnetism. Lodestone, the rock, has a lot of iron in it. A lightning strike on the right iron-filled rock can act like lots and lots of magnet strokes all at one time. Scientists are pretty sure that lightning struck all the places where lodestone is found and changed ordinary stone into a magnet stone. Now you know a lot about what scientists know about magnetism. Even so, sometimes it still seems magical. After all, it goes through air and water, glass and plastic, walls and tabletops. Enjoy this feeling of wonder. Keep exploring with your magnets like a scientist and see what else you can find out. Let's say this word together. Magnet. A magnet is able to attract certain metals. On this page of our book, we see all different kinds of examples of magnets and all the different shapes and sizes that they come in. You can even see refrigerator magnets that you put on your refrigerator. We could use the word magnet in another way. We could say, my mom hangs up my picture on the fridge with a magnet. Let's say this word together. Compass. A compass is a tool that can be used to find direction. Remember, on this page of our book, our mouse friend shows us how to make our own compass so that we can find north and south. We could use the word compass another way. Like we could say, I use my compass on my hike to help me find the river. On the next page of your seesaw assignment, I have this really fun magnetic technology scavenger hunt. I want you to go around and see if you can find all these things in your house or around your house or close to your house that use magnets every day.